iterators in C++, right. So, we studied that containers and algorithms exist, right. These are data structures which are used to store the data, and we apply algorithms on these containers. Okay. On these containers we apply the algorithms using the help of iterators, Okay. So, best simple example to understand is this. See, I have an array int a of 5 equal to some elements 1, 2, 3, 4, 5 like this, 5 elements are there. Then I write a for loop here. In any language you write for I equal to 0, I is less than the size, then I plus plus, right. Then here you write C out of a of I. We write like this. To need presentation I can still give this, right. So, what is this doing here? Using a iterator variable, we are using a iterator variable I, okay, which is helping me to iterate over the container array. Okay. I am iterating over the container, I am traversing the array elements. How am I traversing? In array we say indexing, we use the word indexing. Array indexing is useful for accessing the array elements. So, I say take one variable I equal to 0, a condition, and I plus plus. Here I is called a iterator. Simplest example to understand iterator is this. I is an iterator. Okay. Using this I, I am able to access the elements of the array, right. So, is this I modifying the element? No. You see, to understand this in the general context of indexing or this iterator I, when I have an array like this with elements 1, 2, 3, 5 and 6, we say we have some indexing 0, 1, 2, 3, 4, right. This iterator value is changing, it is moving from 0 to 1 to 2, 3 to 4 and ending here. Iterator value is only, it is not affecting the values you see, it is not affecting the original values of the arrays, it is actually referring to the indexing of the arrays. Okay. Array has some indexing which begins from 0. This iterator I in this for loop is referring to this indexes only. Okay. Based on this indexing logic, it is giving the actual value, but iterators, this also can be called as an iterator. One type of iterator, without impacting the value, you can play with the indexes of the array. That is one kind of iterator. Another iterator could be the values themselves could be iterators. Okay. Value themselves could be iterators. How? Suppose that is what we use. For that case, what we do? We write something like this. In Python programming also we do for auto I colon a, auto I colon a, C out I. What is I here? What does mean I here? I means take the every element of, for loop means for every element of A, copy that first element into I, print it, again go to the second element, copy that into I, print it, again go to the third element, copy that into I and print it. Here this is also an iterator variable, but here this iterator is referring to the content of the array, not the indexing, right. So, iterators on C++ can they help us to play with the values of which are stored in the containers, right. Let us understand them in detail with some examples and types of iterators. Okay. Iterators are the pointer like objects that are used to point to the memory addresses of STL containers. Okay. They are one of the most important components that contribute to the connecting the STL algorithms with the containers. For connecting algorithms with the containers, we use iterators. For that, you have to include iterator header file. Okay. There are so many types of iterators in C++. First one is input iterators. Okay. The input iterator means the one which I said here, that for loop. for I equal to 0, I is less than n, I plus plus, or even this auto I. Let us see that. Input iterators can be used to read values from a sequence once and only move forward. Okay, they can read values auto I for auto I colon A. When I say it is reading element from this A, copying into I, doing some operation inside for loop with this I, then it is moving forward in one direction only. Okay, right. Input iterators can be used to read values from a sequence, can be array or a vector or a queue, once and only move forward. Output iterators can be used to write values into a sequence once and move forward. Input are to read, output iterators are to write. We will see examples to understand them, okay, in detail. Then forward iterators, right? These combine features of both input and output. They are useful, they combine the features of both input and output, right? Next one, bidirectional iterators support all operations of forward iterators, and additionally they can move backward also. Okay, forward iterators will go forward only, reading writing both can be done. Bidirectional can do reading writing and also can come back. Then random access iterators, right? They do front, back and any other random value. Okay, we will explore them in detail about these iterators. Okay, let us study about input iterators, which are useful for reading the values from a sequence. Sequence can be any container, only once and they move forward, once and only move forward. Let us see the input iterators. Okay, so we will come to this theory, we will try to go and see an example and then come to these points. See here, right? So vector int v1, I am having a vector 1 2 3 4 5. I am trying to create a iterator. How to create that? If you want to create a iterator for vector, you have to give the syntax of vector declaration like this: vector int, then the scope resolution operator, then the keyword iterator. Keyword iterator I1 is the name of the iterator, I1. Okay. Now in for loop, I1 equal to v1 dot begin, from this beginning, I1 not equal to v1 dot end till the end, plus plus I, see out star I. That is what, no, it gives the pointer. Star I means it gives the pointer, refers to the memory address. It refers to the memory address of 1. Okay, it refers to the memory address of 1. That is why we wrote here star I1. So beginning, first one address of 1 will be there, it will give 1 2 3 4 5 as it is, right? So we will try to study about this input iterators. This is a simple example to demonstrate. You can create a iterator. You want to create an iterator for array, same thing. How do you create iterator for array? I can write array int here iterator I2, like this. You can create an iterator for array also, for vector also, right? Then you can use that iterator to access the values. I1 equal to the starting address, I1 is not equal to the ending address, print star I1, give the value at that address, that is 1. Then plus plus, increment the value, increment the address, go to the next location, print that value, and so on. Okay, this is about input iterator. Let us come to the theoretical point here. They are the iterators that can be used in sequential input operations, where each value pointed by the iterator is read only once and the iterator is incremented automatically, plus plus I. Usability, they can be used only in single pass algorithms, meaning algorithms in which we can go to all the locations in the range at most once. Okay, when you are searching, linear search, binary search, what we do, linear search means we try to check each element, compare and move forward, compare and move forward. Those kind of things, input iterators can be used. Equality, inequality, yes, an input iterator can be compared. If there are two input iterators A and B, they can be compared like this, because they are pointing to memory locations, no, because they are pointing to memory locations. That is why these things are valid for iterators. You can check like this, right? An input iterator can be compared for equality with another iterator. since iterators are point to some locations, right, they can be equal only if they point to same position, okay, because they are pointing to the locations, addresses of those variables. That is why you can even apply whether they are pointing to same location or not. Iterators can be checked like this. Generally you cannot do in pointers. In pointers, if you are storing address, suppose I have int a equal to 10 and int star p1 equal to ampersand a, same way int b equal to 20, int star p2 equal to ampersand b, right. You cannot compare p1 equal to p2 here, but you can do it here using the iterators. So, whether they are pointing to same location or not can be verified. Next one, dereferencing. Okay. Input operator can be dereferenced, meaning since it is a pointer, you want to know the value at that location, you have to use star. For normal variables and for class variables, you have to use like this. We already studied that you have to use arrow symbol, right. You have to use arrow symbol to obtain the value. So, dereferencing is also possible. That is what we have done here, dereferencing. Incrementable, input iterator can be incremented. See, we are writing here plus plus I1, though it is an address, we can perform post and pre increments. Okay. So, we can do these operations are allowed on the input iterator. Ultimately, we would like to say that input iterators are useful for reading the elements of a given container in a sequence by incrementing one after the other. Okay. It can only read the values. We cannot modify the content of the vector v1 using this iterator I1. Here it is assumed to be input iterator. Next one, the output iterators in STL. Okay. What are these output iterators? Right. So, let us see an example and then come back to the theoretical understanding. Same, I have a vector here v1 with 1, 2, 3, 4, 5. Okay. I have created a iterator I1 here, okay, using the syntax. Then same thing, I1 equal to v1 dot begin, I1 not equal to v1 dot end plus plus I1. See, star I1 is equal to 1. Here I am assigning values. I am updating the values of v1 through this iterator I1. Okay. What it is doing actually, from the beginning till the end of v1, what all values are there, you are replacing them by 1. Okay. So, if you are using a iterator for reading the content only, it can be considered as input iterator. If you are using a iterator to update values of a container, then it can be treated as an output iterator. Otherwise, programmatically there is no difference in writing iterator point. If it is reading, it is input. If it is writing something, it is output iterator. We do not have any difference in the implementation part. Only if you are using this command, it becomes a output iterator. See here, same thing, same logics are applicable for those writing iterators. No, they can be assigned values in a sequence, okay, but cannot be used to access values. They are used for assigning values, unlike input iterators which do not reverse the accessing of values. Okay. So, we can say that input and output are complementary to each other, right. So, we can use again same equality, inequality, dereferencing, incremental, swappable, everything are possible on the output iterators. The main goal is we can update values. That is why when we said definitions of the iterators, see, input iterators can be used to read values from a sequence once and only move forward. Output iterators are used to write values into a sequence once and move forward. Okay. So, these are about input and output iterators in STL. Okay. Again, remaining usability, just like input iterators, output iterators are used only with the single pass algorithms, that is algorithms in which we can go to all locations in the range at most once, such that these locations can be dereferenced or assigned value only once. We are assigning value only once like this. Okay. So, what is output of this program? After doing this iteration, the V1 vector will become 1, 1, 1, 1 and 1 like this. Okay. It has all the elements as 1, right. So, this is about input and output iterators in STL.